Okay, we're now looking at some surd basics, and we're looking in this video at multiplying and dividing surds. Okay, so if we're looking at multiplying surds like root 2 times by root 5, okay, you may already be familiar with, well, if you're timesing two individual surds, you can just square root the whole thing and times your numbers together. Okay, so here we can just simply take this to be the square root, and then we can go and do 2 times it by 5. These two mean the same thing, okay, which is equal to 2 times 5 is 10, so the square root of 10. Okay, it is quite a simple law, but to be honest, right, the proof of this is a little bit more complex, and similarly for dividing, a bit more complex. Okay, so in the next video, I'm going to show you in more detail by proving why this statement is actually true, why you can just simply go and take your two numbers and times them together over the same surd. So in the next video, I'll prove this statement and this statement to you. But actually, right, this is something that you've actually seen before very recently with our work on indices, okay? Because remember we said previously on the last video that, well, all of the laws of indices apply to surds. We've seen this rule before with indices, okay, written like this, where we wrote it as a to some power n. We're timesing it by a different number, okay, to the same power, because if you're square rooting here, the power here is going to be to the power of a half. You've got the same power. That is the same thing as doing bracket a times by b to the power. You've seen this law previously with indices, just now applying it with surds. Okay, so these two things here mean the same thing, just this one is in terms of surds, in terms of indices, but again, I'm going to prove to you in the next video why we can just go and simply take our two numbers, times them together, and put it under the same root, or in terms of indices, the same power. Okay, but it is, for the time being, all you need to really know is, okay, it is as simple as just doing this. So similarly, right, it follows for division that if you're dividing two individual surds, like we are here, root a divided by root b, you can just write underneath the same surd sign and say this is the same thing as doing the root of 15 over 3. Okay, 15 divided by 3 is 5, so it's the same thing as root 5. Okay, so this is simply your answer. And again, you've seen this law before with our work on indices. Okay, we wrote it, in terms of indices, we wrote it as a to the power of n divided by b to the power of n. So looking at different numbers but with the same power, because the powers here are just square rooting they're the same power, and this was equal to a over b to the power of n. So we've seen this law and this law before with our work on indices. Okay, but to be honest, right, you just need to know really that, okay, for dividing surds, you just write it as one big surd. And that is it. So we'll go through some my turn, your turns. Okay, so I'll go through these three my turns and you can try the your turns, and that's going to be it for this video. Okay, so the first one, we've got root 4 squared. Let's write this out in a bit longer format. This is the same thing as doing root 4 times by root 4, because if you're squaring something, you're timesing your number by itself. Okay, and then we can use our law of surds that we've just seen, which is, I'll write it up here, that root a times by root b is equal to root a times by b. So this is the same thing, it's just timesing your numbers underneath the same surd. So that's going to give you root 16. Root 16 is equal to plus or minus 4. I'm just going to keep it as 4 for the time being. Okay, that is simply your answer. But again, right, if you think about this also, because remember surds and indices work in the same way, you're just writing them in different formats. You could have written this, if you wanted to, the square root of 4, okay, is the same thing as writing it as 4 to the power of 1 over 2. And if you're squaring it, okay, we know from our laws of indices, okay, we can just times those two powers together to give you half times by 2 is 1, which gives you 4 to the power of 1, which is just 4. The same thing as what is over here. So it's quite nice, right? You can really see that they are the same thing, just written in different ways. Okay, next one, we've got 3 root 5 times by 4 root 7. Let's really look at this in a bit of detail. 3 root 5 means 3 times root 5. Okay, if things are grouped together, you're timesing them. So if we write this in long format, we've got 3 times by root 5. We're then timesing this by 4 root 7, which is 4 times by root 7. And then simply all we're doing here is we consider our number parts, which is 3 times 4, which is 12. Then we're timesing this by root 5 times by root 7. And we now know, right, if you're timesing individual surds, you can write it underneath one big surd. So we can write this simply as root 5 times by 7 is 35, so root 35. Okay, so we've got 12 times by root 7. Of course, we can simply write that as 12 root 35. Okay, and that is your answer. Brilliant. So you just consider your number parts, times them, your surd parts, you times them, which is good. Our next one, very similar, but this time we're dividing. So again, if we want to look at this in a bit more detail, we've got 20, sorry, I've got my things in the way, 20 root 30 divided by 5 root 3. Divide your number parts, 20 divided by 5 is equal to 4. You've then got root 30 divided by root 3. Okay, so again, you can write underneath the same surd using our laws of surds. So root 30 divided by 3, or 30 divided by 3 is 10. So we can just write it as the root of 10. Okay, so 4 root 10 is simply your answer. Okay, good. So you can now pause video, you can try the 3 your turns, and we will go through these now. So the first one, okay, we've got root 2 cubed. What if you're cubing a number? Right, we're doing your number, root 2, you're timesing it by itself 3 times. Okay, so there we go. So if we look at the first 2 surds, okay, we can write this as root 2 times by 2, okay, which is equal to root 4, okay, which is 2. So root 2 times by root 2 is 2, and you're timesing this by root 2. So you've got 2 times by root 2, which is just simply equal to 2 root 2. And this is your answer. Okay? Good. Again, you could have considered it in terms of indices if you wanted to, right? Because again, right, root 2, we could have written, let's do it over here, root 2 is the same thing as 2 to the power of a half, and then you're putting it all to the power of 3. Again, laws of indices, the power law, okay, you can times those together to give you 2 to the power of 3 over 2, which is the same thing, actually not particularly clear in this case, is it? But that is the same thing as this over here, okay? Good. And the reason is, right, probably going into a bit too much detail now, right? If you want to break this up again further, you can write this as 2 to the power of 1 times by 2 to the power of a half. Because 1 times by 2 times 2 to the power of a half, add the powers, 1 add a half is 3 over 2. Okay, and of course, this is the same thing as 2 root 2. 2 to the power of a half is root 2. Okay, good. That's that one. This one, we've got 7 root 2 times by 3 root 5. Again, consider your number parts and then your surd parts. So we've got 7 times by 2 is equal to, sorry, 7 times by 3 is 21. You've then got root 2 times by root 5, which is going to be equal to the square root of 10. You just times them underneath the same surd, and that is simply your answer. Okay, so let's give that a highlight. Excellent, good. Last but not least, okay, very similar, but this time we're dividing. We're doing 8 divided by 4. 8 divided by 4 is 2. We've then got root 14 divided by root 2, which is equal to root 7. 14 divided by 2 is 7. So simply, this is your answer. Let's do it in yellow. Keep it consistent. There we go. Excellent. So, look, hopefully this is fairly simple stuff on, because you might have seen this before at GCSE. Hopefully you would have done on timesing and dividing surds, but you'll see in the next video, we're actually going to prove these statements. So why we can just go and take this to be true, and why we can take this to be true. Okay, but hopefully that was useful. Thank you for watching.